Assalamualaikum and hi everyone. My name is Nur Farhana binti Tahir. You can call me Miss Farhana and I am from SMK Seri Gombak. Before we start, please prepare your Science Form 1 textbook and stationery. Today, we are going to learn about 3 states of matter in nature. If you have your textbook with you, you may refer to page 145. By the end of today's lesson, you should be able to 1. Generalize that matter consists of particles. 2. Compare and contrast 3 states of matter based on kinetic theory in terms of arrangement and movement of particles. Now, please take a look at the picture. Pupils, do you know what this is? Yes, this is a gold ring. Is this gold ring a metal? Yes, it is. Thank you for your quick answer. Now, what is this gold ring made up of? The gold ring consists of gold particles only. But we cannot see the gold particles with our naked eyes or even by using a light microscope. Matter is made up of particles which are tiny and discrete. These particles are called atoms or molecules. Atoms, when they are joined together, become molecules. Before we proceed further with this discussion, let us think about the concept of particles. Let's do a demonstration to show that matter is made up of small and discrete particles. You may refer to activity 5.4 on page 145 in your textbook. Before we start, please wear a pair of gloves for safety purposes. First, prepare 5 empty beakers, a glass rod, a spatula, potassium permanganate crystals, distilled water and a 10 ml measuring cylinder. Next, prepare a concentrated solution of potassium permanganate by adding 40 ml of distilled water into a beaker and a few crystals of potassium permanganate. Stir well by using a glass rod to ensure that all the potassium permanganate crystals are dissolved in the water. What can you see? Yes, the solution is deep purple in color. Now, take 10 ml of the prepared potassium permanganate solution and pour it into another empty beaker. Distill water until it reaches the 40 ml mark. Stir the solution well. Now, you have 2 potassium permanganate solutions. Repeat the procedure by taking 10 milliliters of potassium permanganate solution from your second solution and add distilled water until it reaches 40 milliliter mark to prepare your third solution. Stir the solution well. Repeat this procedure for your fourth and fifth solution. Now, you have 5 beakers of potassium permanganate solutions with different concentrations. What can you see? Yes, very good. The color of potassium permanganate solution becomes lighter each time you add distilled water to the solutions. It means that the solution becomes more diluted when water is added. Why does the color of the solution get lighter? Well done! It is because the number of the water particles has increased. So, from this demonstration, what can you conclude? Very good. The conclusion from this activity is that matter is made up of small and discrete particles where the potassium permanganate keeps on dividing to fill up the empty spaces between the water particles. Refer to this demonstration from left to right. This demonstration tells us that a few drops of colored liquid are still able to color a large volume of water because the color of the liquid is a matter which consists of small and discrete particles. The color of the liquid keeps on dividing to fill up the empty spaces between the particles. Alright pupils, now let's discuss the theory of particles. The particles in matter are extremely tiny, which we cannot see with our naked eyes or even with the light microscope. However, the particles can be seen through an electron microscope. Next, they are always moving and attracted towards each other. Even though they are close enough, there will be empty spaces between the particles. And lastly, if you heat up the matter, the particles will move even faster. Now, let's talk about matter. Matter can exist in three different states, which are solid, liquid, and gas. In solid, particles are close packed in an orderly manner. There is a strong force between the particles. They only vibrate and rotate on their fixed positions. This explains the fact that a solid cannot be compressed and has a fixed shape. Solid particles also have definite mass and volume due to the strong attraction between the particles. The motion of the particle is also restricted. Particles in a solid are in their lowest level of kinetic energy. Next, the second state of matter is liquid. In liquid, the particles are less close packed and are not arranged in an orderly manner. Particles are free to move but are still attracted towards each other. The particles glide over one another and the forces between the particles are weaker than the forces between the particles in a solid. This explains why liquid has a definite volume but has no definite shape. It takes the shape of the container. Liquid is also hard to compress as the empty space between the particles is less. Particles in liquid have a higher kinetic energy as compared to solid particles. They hit one another regularly. The third state of matter is gas. In a gas state, particles are far apart from each other. There is a lot of empty space between the particles in gas. The forces between the particles in gas are the weakest as compared to the forces between the particles in solid and liquid. This shows that gas is easy to compress and has no definite shape, mass, and volume. Particles in gas have the highest kinetic energy as compared to solid and liquid particles. They can move freely and randomly. The particles also hit one another often. The rate of collision between gas particles is greater than the rate of collisions between liquid particles. Now, pupils, you have learned about the three states of matter based on their arrangement and movement of particles. Can you state some examples of solid? Well done! Some examples of solid are a box, carrot, and table. How about liquid? Yes, here are some examples of liquid. They are juice, water, milk, and oil. Now, let's take a look at the examples of gas. Can you state some examples of gas from the picture? Yes, you are correct. These are examples of the state of gas that we can see in our daily life. The air around us is one of the most common examples of gas. But what about the last picture? Yes, it is cooking gas. Cooking gas such as methane and butane is in the form of gas. Boys and girls, what is the most common example of substance that we can see in our daily life? If your answer is water, you are right. Did you know that water can exist in all three different states of matter? Water exists as ice when we freeze it and become liquid water when it is heated. And the liquid water changes to water vapor when it is heated at a higher temperature. Now, let's recall the definition of solid, liquid, and gas. You may define states of matter in a simple manner. Solid is a substance that maintains its shape even without a container, but liquid takes the shape of its container while gas spreads out to fill the container. Boys and girls, how do you categorize a substance that doesn't seem to fit these simple definitions for solid, liquid, and gases? Well, here are some examples that are commonly found in our daily life. They are sand and shaving cream. Let's take a look at sand first. In the first picture, sand looks like a solid, while in the second picture, sand takes the shape of the container and has the ability to flow. This fits the characteristics of a liquid. In the third picture, sand can be spread out into the air. Now, take a look at the sand in the hourglass. Does the sand take the shape of the glass? Correct. The sand takes the shape of the glass. Now, my next question. Does that mean that sand is a liquid? Good. Even though sand seems to take the shape of the glass, sand is not categorized as liquid. Each tiny little piece of sand is a solid, but the pieces are so small that when you turn the hourglass upside down, the sand flows through and takes the shape of the container. Sand is a solid but acts like a liquid because it's tiny pieces that takes the shape of the container. Next, pump some shaving cream onto the petri dish. It looks like a small little mound, doesn't it? If you don't touch it, does the shaving cream maintain its shape without a container? Correct. The shaving cream maintains its shape. Does this mean it is a solid? No. If you look very closely at the shaving cream, it is actually a liquid which contains many tiny gas bubbles. So, it is really a mixture of a liquid and a gas that together forms its shape like a solid. until you touch it. Well, boys and girls, with this session today, you are now able to first, generalize that matter consists of particles. Second, compare and contrast three states of matter based on kinetic theory in terms of arrangement and movement of particles. I hope you have enjoyed today's lesson. Goodbye and thank you.